In this video, we will learn about work done by a constant force in the direction of displacement. Now let us consider a constant force F acting on the block kept on a smooth surface and displaces the block in S direction from the initial position A to final position B. Now the displacement here is S. Okay, so the work done, which is measured as the product of magnitude of force and the displacement, would be F into S. Work has only magnitude and no direction, thus we can say it is a scalar quantity. Also, if the displacement of the object is at some angle to the direction of the applied force on it, then work done is given by the product of the displacement and the component of force along the direction of displacement. Now, what the last line means is, suppose that this is your object and this is how you are applying a force, which is theta away from this particular horizontal line, and the box is moving in this direction. Then if the displacement is in this direction, then I'll take the component of this force in this direction. That would be F cos theta. Okay. Now here you can see that force has two component. This F force has two component. One which is this F cos theta, and one which is this F sin theta. Now the displacement is happening in this direction, so I can say that this component of force is responsible for the displacement. So work done in this particular situation would be F cos theta into displacement. Okay. Now general expression for work done. Now let an object moved on a smooth surface from position A to position B covering a displacement S by a constant force F, which is acting along a direction inclined at an angle theta from the direction of displacement. So this is the force. Okay, this is the direction of displacement, and this force is at theta degree away from the displacement, or inclined away from the displacement. Now the component of the force which is acting in the displacement direction is F cos theta, and the component which is not acting is F sin theta. Okay, so we will consider this component of force and this is our displacement. So work done in this particular case would be F cos theta into displacement, that is Fs cos theta. Now this equation gives the general formula for work done. Now as per this relation, work done by a force on an object is given by the product of the magnitude of force and the displacement and the cosine angle between the direction of force and the displacement. Now let us consider three special cases. First is if the force and the displacement are in same direction, then we can say that theta here would be 0. Now in this particular case, cos 0 degree would be equal to 1, and work done we get is force into displacement directly, right? In such a situation, work done is positive and has a maximum magnitude. Second condition could be that force and displacement are in opposite direction. This mainly happen in case of friction. Now here the theta is 180 degrees, and we know that cos 180 degree is equal to minus 1. So work done here we will get is minus F into S. Okay, now the work done is negative, although the magnitude of work done is still maximum, but its sign is negative. Third is when force and displacement are mutually perpendicular to each other. In this particular case, theta here is 90 degrees, cos theta here would be cos 90 degree, which is equal to 0. That means that work done would be equal to 0. Thus we can say no work is done by a force on an object when force is acting at right angle to the direction of displacement. I hope this topic is clear to you. Thank you.